Sound speeds. Let me start by saying this. Deity did not ask me to make this video. They're not compensating me for this video. They're not involved in the production of this video in any way, shape, matter, or form, or in any other way. This is my doing. Now, why am I starting by saying that? Because although in my review of the BP-TRX I said this, the Deity visually stayed in sync with the TS2 timecode slate for over 10 hours that I tested them together. There are people on the internet putting words in my mouth and saying that I said things that I didn't say. Imagine that on the internet, right? Now, I understand the confusion though, because I spent the entire timecode portion of the video talking about the display and how it drove me crazy as opposed to testing the accuracy. And although I thought I made it very clear when I said this, it's difficult to tell which one is exactly right. And then went into proving my issue that the OLED display on the BP-TRX is, to be direct, terrible at displaying accurate timecode. And although I did say this, but short of starting with a master time clock that has an accurate display, jamming a BP-TRX off of that, and then using that BP-TRX to jam another BP-TRX, and then outputting both of those into smart slates, and then comparing the displays on the smart slates to the actual original master time clock display, it's a lot of work. Let me just put it that way. If you really want me to do something like that, put it in the comments below. And nobody did. But I also did say this. The BP-TRX does a lot of things, and I couldn't possibly test them all. And even if I did spend a couple of months doing that, all it would take is Deity doing a firmware update and probably invalidating most of my tests. And sure as the world, Andrew from Deity was texting me the day my review dropped with a firmware solution for my complaint about the OLED display. He worked with his engineers, and less than 2 days later, he was personally running multiple tests on a firmware that had a 30 frames per second refresh rate. And when he was satisfied with his test results, he shot it my way to get my thoughts on it. Now my BP-TRX units have the updated firmware that will be included with the next update, and supposedly it fixes the timecode display issues that I did not like before. So naturally, I'm going to have to test that. I borrowed and bought a lot of things that are going to be in today's testing. From sound mixer Aaron Siegel, I borrowed not one, not two, but 3 Deity TS2 timecode slates with integrated sync boxes. And then I bought a whole bunch of cables and adapters that are going to be used in the testing. So let's start off by counting the display frames like I did in my BP-TRX review. If it can display 30, it can certainly display a lower frame rate, so I'm going to go for broke and see if it can count all the way up to 30. I'm currently in post, counting the number of frames versus the frames displayed on the screen. And let's count together. Frame advance one time, and we hit frame 26. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 15 frames right here is when this changes from 26 to 27 frames. So we're going to label it as such. And then we're going to advance some more. 1, 2, 3, 4, 5. 5 already. So we're going to split the track again and go up to 28 frames now. And then we're going to continue to count up to 29. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. Let's back up 1. Yep, 14 is definitely 28. So we're going to split the track again and call this 29 frames. Now, here's a very interesting thing I found while doing this counting. If you notice, each of these frames, it changes, right? 26, 24, and they're all labeled correctly. But look at the amount of time that is displayed on the screen. 5 frames, 15, 5, 15, 5, 15, 10, 10, 10, 10, or that's 5, 15, 5. Although it is playing 30 frames per second, each frame is not staying a 30th of a frame on the screen. They're actually fluctuating up and down, some frames staying 3 times longer than others. So why don't we go ahead and test the accuracy? I used one BP-TRX unit to jam one of the TS2 timecode slates, and upon disconnecting it, that slate became my master time clock. And I used that master time clock to re-jam the BP-TRX torch. And once that was done, I used that torch to jam another BP-TRX unit. So supposedly, if they're all accurate, they should have exactly the same timecode. Although displaying accurate timecode is important, the most important thing is for it to output accurate timecode as long as possible. Now, my original plan was to split the output of both BP-TRX units and the master time clock and split that, where one side went to an external display and the other side went to a multi-track audio recorder. But 2-day shipping has now been over a week. Thank you, UPS. So I'm going to have to do 2 separate tests. I decided to start with a 12-hour audio recording, where I took an output from the timecode slate and the two BP-TRX units for 3 tracks going into my Sound Devices Mix Pre 6, which allowed me to multi-track record them all together, and then allows me to bring it up in my DAW where I can look at the files. I'm going to open the 12-hour long track that I recorded on my Sound Devices Mix Pre 6 in Reaper. Now notice it is a broadcast WAV file consisting of 4 tracks, all integrated into one. And this is because there is a mix track followed by the TS2 track and then the 2 BP-TRX tracks. In order to compare the tracks, I'm going to have to look at them individually, which means I'm going to have to select all the files, go over to processing, and then explode them into individual channels. This is going to take a while. Thanks to this time lapse, a few minutes for me has been reduced to a few seconds for you. Before we go any farther, the first thing I'm going to do is label the 3 tracks I care anything about. The first one is the Deity TS2 Master Time Clock, the second is the BP-TRX Torch, and the third is the BP-TRX Jammed. Because both Deity units were jammed from the same master sync box, neither one of them should ever show a timecode that's before the master sync box. And because the BP-TRX jammed unit was jammed from the Torch, it should never show a timecode that is before that of the Torch timecode. So unless things drift in a very weird way, the TS2 should always show a timecode that's before the BP-TRX Torch, and the BP-TRX Torch should always show a timecode that's before the BP-TRX Jammed. Now that everything is ready, what I'm going to do is isolate the 3 tracks from the rest of them and get rid of the ones that we don't care anything about. So now we have only the 3 tracks that we care anything about. 12 hours of audio right here. And first thing we're going to do is go into Effects, and we're going to look for the Longitudinal Timecode and Society of Motion Picture and Television Engineer Timecode Reader. That's right there. And this is going to be for the master clock. The next thing is going to be the exact same thing, but for our BP-TRX Torch. And the third is going to be for our BP-TRX Jammed unit. Now we should be able to see the accurate timecode from each of the devices when I play them together. For easier viewing on each of these tracks, what I'm going to do is normalize all of them. And I do want to point out one thing when I do this. Oh, that's interesting. Those two didn't normalize properly. What I do want to point out is that if you do normalize all of these tracks together like this, notice that the timecode slate, the Deity, is 15 dB hotter than it is on the 2 BP-TRX units. Now, that's not really a big deal. It's just something to take note of. Now, I'm going to go up only about there. I don't want to make it distorted. And then over here, you're going to increase up all the way because you're never going to maximize there. Okay, so let's go over here and look at what it would look like if we are right at the very beginning. So before the clock resets, everything is in perfect sync. You can see right here, 777. And notice right here, everything pretty much seems to be in alignment. The audio seems to be perfectly in sync. Oh, that's interesting. Look at this. This right here, this time code is actually inverted phase-wise. So this here, you see this big right here and then the little skinny one here? This is actually dipping down. So this BP-TRX unit was actually out of phase. This isn't a big deal though because we're dealing with time code, but it's just something kind of interesting I find that it's inverted in phase. Okay, so let's go ahead and zap ahead a little bit and see what happens at, let's say, about the 30-minute mark, roughly around here. Play a little bit and then hit pause, let it kind of get it in sync a little bit. Okay, so everything looks like it's more or less still in sync if you look at the time code and how it's kind of aligning itself. There's a little bit of a skew right there from the, there's little imperfections as it will play, and that's to be expected. The big thing is all of this is code and it's transmitting digitally. Or not really transmitting, but it's transferring digitally. So it's just going to play back and it's going to pretty much display correctly. There may be an occasional anomaly, but either way, let's play about 1 hour in. Okay, notice now, this is the first time we're an hour in and the master time clock is actually 1 frame ahead of the 2 BP-TRX units. Now, keep in mind that while I'm assuming that the BP-TRX units are, you know, I'm considering that the Deity is going to be the master time box that I'm going to be considering to be the industry standard that is the one that's actually frame accurate. But the BP-TRX units are staying pretty well in sync with each other also. So far, there's less drift from the 2 BP-TRX units after the initial slight drop, but they were all in sync together. For all we know, the Deity could be drifting a little bit ahead, and the 2 BP-TRX units are exactly where they have always been, or they could be drifting slightly behind. It just really doesn't matter what it is, because they're not drifting very much right now. But what I will say is, if you look at the very beginning, they were all very much perfectly in sync. I mean, more or less. If you look right here, the jammed unit was ever so slightly, it's only one sample behind. That's like 1/48th of a thousandth of a second. So it's not a very big deal. Now let's go ahead and jump like 2 hours in and see what happens if we hit play around there. Just before the 2 hour mark, and we're still about 1 frame ahead rather. And if you look here, the BP-TRX units are slowly starting to drift away from the TS2 timecode slate. And we don't know which one is drifting in which direction, but I would assume, and this is just an assumption, that the TS2 is going to be the most accurate of them because it is an industry standard. Its entire job is to just do what it does. Okay, now they're all back in sync again. If you look at the time code, it's probably going to be fairly close. So there we go. And even right at this point, like let's just look at the very beginning here, over to the beginning there, we're talking 9 thousandths of a second, and over to the jammed unit is only 14 thousandths of a second. So we're still well below one entire frame. So even though it's showing, sometimes 1 frame off, it doesn't necessarily mean that it's very far off. Like for example, we'll look over here and see what happens. 4 hours in, everything's back in sync again. Let's zap ahead a little bit more and see what happens at maybe about 5 hours. Okay, so now the master time clock is now a little bit ahead by about 1 frame. And look here, it started to pull away a little bit. Now, if I were to measure from here over to here, where's the back of that part? Maybe right around there. Is that what it is? Something like that. It's only about, well, how far was that? We're talking 15 thousandths of a second. And over to the next one is only 24 thousandths of a second. So we're still below a frame. And let's go ahead and go about the 6 hour mark and see what happens. So now we've completed our morning and everything's back in sync. I'm going to do it one more time. So more or less, they're pretty well in sync. If anything, there's a drift of maybe 1 frame on the BP-TRX units from the TS2. And again, it could be that the BP-TRX is perfect and the TS2 is running slightly fast. Remember, these are all battery operated. So this is the alignment right here. These frames are where they would line up. Same thing. So these are all in a line here. It doesn't go this way. This is all in alignment here because this time code has to have hit first. So this would change over to 5, and these still have not passed by yet. Okay, we're still about the same 1 frame ahead. Let's zap ahead to about there. Hopefully now we're meal penalties and everything. We're at lunch, if at all. And we're only 1 frame in advance. So now, you see, we're starting to pull away a little bit. We're only 21 thousandths of a second. So we're still very close and not really enough to fuss about. Let's zap ahead a little bit farther. Okay, we're now in sync on the first 2, and the jammed unit is starting to drift a little bit away. So if I were to zoom in way here, you're going to see this unit here. So it's probably like this time code here, most of this time code here. The first numbers have changed here. The first numbers have changed here, or the last. I don't know how this thing works, to be completely honest. I'm not a time code engineer, but this number here has not changed. So if you look right here, maybe this is a separator. These are the separators between the frames, perhaps. And it's sort of drift behind a little bit. So that gets you through a morning. It's all accurate until about the 7 hour mark. Let's zap ahead a little bit more and see what happens in about maybe 8.5 hours. Okay, so now it's the first time that we've seen it where all of them are showing about 1 frame drift off from each other. And so that means that this is probably here, this one's here, and this one's here. And we're probably part of the way, and this is like a frame, this is a frame, and this is a frame. Okay, let's zap ahead a little bit more and look at it again. And they're more or less in sync, except the time code, the last one again. So these are all fairly close. Let's look at about the 10-hour mark. Okay, about 1 frame drift. More or less the same on the BP-TRX units and 1 frame drift on the TS2. 11 hours in, and we're having 1 frame drift difference between the TS2 and the BP-TRX. Now let's go right for the very, very end here. 12 hours in. And pause. So they're all the same. The 2 BP-TRX units are the same. TS2 is slightly ahead. Okay, so you see right here, if we were to zoom way in here, this is probably the first frame, that's the next one, that's the next one. So it's probably this here, and this here, because this is a full frame off. So that would be a full frame at 34 milliseconds right there. And that's what gets us to our first frame of latency right here, right there. And then by the time we get over here, we're about 56 thousandths of a second off. So like 500ths of a second off by the time we get to this one. So more or less over 12 hours, there's only a little bit of drift here. I know it seems like a lot, but you got to keep in mind, these are all battery powered devices that are all staying in sync because of their integrated temperature compensated crystal oscillators. And it's staying very well in sync. Of course, you would like them to be perfectly in sync with the master clock, but it's never really going to be the same. This is an adequate amount of drift for what we're doing here. The timecode itself was not changed as part of this firmware, only the display was, so my original statement of being accurate for 10 hours plus is still holding true. Now, what about the drift? Guess what? Drift happens. You have 2 devices that are trying to stay perfectly in sync with each other over 12 hours, and if you drift more than a 30th of a second in our case, it's going to display 1 frame off. Oh my gosh. Well, guess what? That's going to happen on all professional devices, not just the TS2 and the BP-TRX units. And here's what's perhaps happening. You have one that might drift maybe 10 milliseconds over a couple of hours in one direction, and the other might drift a little bit the opposite direction. And then they might kind of do this number 2 and slowly start to fall out of alignment, and they might come back. Who knows what's happening in the minds of these devices? The point here is they are, in my opinion, accurate for at least 12 hours when you talk about the output of the BP-TRX units. And that's extremely good. If you're that concerned about it, then definitely you can rejam after 6 hours and it's not going to be an issue. Now, sure, multiple tests like this would display perhaps anomalies and maybe show trends of one drifting ahead than the other. But guess what? It's still, as far as I'm concerned, accurate. But what about the display? I asked on Twitter for my friends and followers to tweet me a time code between 0 and 12 hours, and at those time codes, I'm going to compare the drift visually. Everybody chose time code between 0 and 8.5 hours, and considering that you're most likely going to rejam before then, I won't carry the test past that. And despite my detailed explanation of accurate time code and examples, some people didn't get it, so in the words of Curtis Judd, you're excused. I started by once again setting the time code on the BP-TRX unit and jamming a slate, which would then become our master time clock. I then went out of that slate sync box and back into the BP-TRX torch. Then I jammed the second BP-TRX unit off of that torch. As you heard me say in the BP-TRX review, I trust the slates to display the received time code accurately. So I turned off jam on each of the side slates so that the numbers would only advance when the slate was receiving time code. Since the BP-TRX units output a constant timecode stream, the slate should display frame-accurate timecode. This will allow us to compare the timecode from the master clock to the BP-TRX displays and the slates that are displaying the output timecode from the BP-TRX units. Now let's look at the 12 timecode freeze frames. This is our master time clock. This BP-TRX unit is our torch, and it was jammed off of this master time clock, and its output is being displayed here. Now, this audio time code is being displayed frame accurate by this Deity TS2 time slate. Now, this BP-TRX jam unit was jammed off of the torch, and it is outputting to this slate right here. So, in our first time code freeze frame, which is 0, 29, 29, 29, they're all in perfect sync with regards to the time code that they're outputting. But the display on the BP-TRX units is 1 frame ahead. Let's go ahead and zap ahead to our next freeze frame. And at 01010101, they're all displaying the exact same, and our BP-TRX units are approximately 1 frame ahead. Zapping ahead about 10 minutes. They're still all in, remaining in the same kind of sync, status quo. And here, all the exact same thing. This is 1 hour and 10 minutes in, 1 hour, 17 minutes in. And they're all about the same. I know it's kind of hard to see sometimes the display. I probably should have used a faster shutter, and I do apologize about that. So let's see, 9, 9, and 9. These are all accurate. Now this here is very interesting. Oh, that's a 3. That's a 3 right there. And that is a 3, and this is a 4, 4. So it looked like a 9. Caught me by surprise at first, but it is definitely a 3. It's kind of hard to see, but there's a little bit of residual, I guess the word is, luminescence right there. Now let's go ahead to the next one, 0, 1, 0, 1, 0, 1, and 2. So remaining in sync, 16, 16, 16. Remaining in sync, more or less the same, 6, 6, 6, 6, 6. Okay, so now these BP-TRX units were 6 hours in, and they're all in perfect sync. All the 6s have pulled it in sync. That's very interesting. Okay, 0, 0, 0, and 0, 0. So it is slightly starting to display ahead. It almost looks like a 2 there, but I'm sure that's not the case because it's now going to synchronize itself up again. Okay, so we're at 1, we're at 0. They're all within 1 frame. Okay, 7, 7. That's a 6 right there, and this is a 28 and 27. So that all makes sense here. This is displaying 1 frame ahead of its output time code. So that's 28, 27, it looks like there. And that's 27. Okay, so that's our last one. 8.5 hours in, so the time code is displaying relatively accurately off the BP-TRX units, and the time code that's being output is displaying excellent on these time code slates. Keep in mind that we don't normally record audio at a 2997 frame rate. That's extremely rare. This was just a test of the BP-TRX's OLED display at a maximum 30 frame per second refresh rate. That's it, nothing more. And also keep in mind that the shutter speed on my camera was only set to 1/30th of a second. So if it happened to be changing in the middle of a frame, then you're going to see, likely those 2 frames starting to blend just a little bit. But still, we were able to see accurately, when I looked at them properly, what each frame actually said. Now, at the beginning of this video, when I counted the frames, that was done at a higher shutter speed so you could see it accurately there. So after careful consideration, I give Deity 2 thumbs up on their time code, provided you install the firmware that updates the frame rate to 30 frames per second. The other old 20 frame per second frame rate, which is all over the place, that thing I never want to see again. That thing drives me completely crazy. This new firmware, though, makes me happy, and that's where I give my seal of approval on the firmware that has a 30 frame per second refresh rate. If you have not already watched my very detailed review of the Deity BP-TRX, then you're going to want to click the link at the end of this video, which is in about 8 seconds. You'll see it pop up there. Thanks for tuning into this episode of SoundSpeeds. Be sure to tune in the future for more deep dives, extremely detailed product testing, and sound advice. Have a question you'd like answered or want to add something? Be sure to write it in the comment section down below. You can also make a suggestion for future topics of discussion. Again, comment section down below, or you can email me at soundspeeds@yahoo.com. Be sure to subscribe and turn on notifications so you won't miss out on future sound advice.